Okay, so we are going to be doing part 2 of our cross-section of volume lesson. So we have a shaded region right here, and it's labeled R, and they give us the point 9, 6. And I'm going to read the directions here. Let R be the region in the first quadrant bounded by the graph of y equals 2 root x, and the horizontal line y equals 6, and the y-axis is shown in the figure above. So I'm going to label all those things. They give us y equals 2 root x, y equals 6. Region R is the base of a solid. For each y between 0 and 6, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base in region R. Write but do not evaluate an integral expression that gives the volume of this solid. Okay, so I'm just going to draw my best depiction of what this is going to look like here. So this is a perpendicular to the y-axis. I'm just going to pick a spot. So that would be the base of a rectangle. And it says that the height is 3 times the base. So it's actually going to be pretty tall. My dog is making strange noises. So something like that. And obviously up at the top here, you're going to have a really big rectangle. Down at the bottom here, we have smaller rectangles, and then it connects. So you've got this base, like if we use Play-Doh here, we'd want the Play-Doh to be right in the shaded region. And then we're going to build this Play-Doh up so that when we cut it like this, so slice it perpendicular to the y-axis and open it up, we get these rectangles that are pretty tall. So first thing I want is I would need an area formula for a rectangle. So I'm going to write that down here. Area equals base times height. So let's find the base first. Here's the base of my rectangle right here. So I need that distance right there. So this distance is the distance away from the y-axis. So this is when we want our formula to be in terms of y. So I'm going to take this and I'm going to solve for x. So I would divide by 2, and then I would square both sides. So x equals y squared over 4. So that's my base. The height of our rectangle is 3 times that, so 3y squared over 4. So I've got a formula. So now I'm ready to write my integral, and we don't even have to solve it. So the volume would be the integral. Now, since we're using y, we want to use our boundaries on the y-axis. So on the y-axis, the shaded region goes from 0 up to 6. Of our area, and we just have the formula there, base y squared over 4 times the height, 3y squared over 4 dy. Now you can simplify this if you want. You can write this as 3y to the 4th over 16, or you can leave it. And if you had to solve it, you could just plug that right into your calculator. Okay, so let's try the next question. This is a 2-part question. Let R be the region in the first quadrant enclosed by the graphs of 2x and y equals x squared as shown in the figure to the right. Okay, so I'm going to label that. This is y equals 2x, it's a straight line. And then we've got y equals x squared is the curved line. The region R is the base of a solid. For this solid, at each x in the cross-section perpendicular to the x-axis, the area is equal to sine of pi over 2x. Find the volume. So they actually already give us the area formula. So we're saying that we're taking a cross-section perpendicular to the x-axis. It doesn't really tell us what the shape is, but it tells us the formula for the area. So we're already ready to set this one right up. So I need the integral. So we're going from 0 to 2 on the x-axis. And my formula is sine of pi over 2 x dx. And that's it. So let's use our calculator for this one to solve it. So I'm going to go to Math 9. Now remember, if you're on the Inspire, you're going to go to Menu, Calculus, and then Integral. So I'm going to go to Math 9. Make sure you are in radians. I'm in degrees, so I'm going to switch that over. So back to Math 9. I'm going to type it in exactly how I see it. 0 to 2. Sine of pi over 2 x dx. Whoops, I accidentally hit graph, so give me a minute. It's graphing something from an old thing. There we go. Okay, there we go. So dx. Okay, so you should get 1.273. If you're on the Inspire, you probably got 4 over pi, so that is the same exact decimal. So let me write that in. So that's approximately 1.273, or it's equal to 4 over pi. So this is our approximate answer. This is our exact answer. Okay, part B. So I'm going to change colors for this one. Another solid has the same base r. For this solid, the cross sections perpendicular to the y-axis are squares, right? But do not evaluate an integral expression for the volume. So this time we've got our perpendicular lines to the y-axis, and they're squares. So I just need a formula for the area of a square. So we know that is area equals base times height. The problem is this is perpendicular to the y-axis, so I need these formulas in terms of y. So I'm going to do a little converting. So here x would equal y over 2. And here x would equal plus or minus the square root of y, but since we're in the first quadrant, it's the positive square root of y. Okay, so to get this distance here, if I turn my paper sideways, right, if we want the distance between two lines, we always take the top, which is the furthest distance, minus the bottom, which is the closest distance, and that gives us the distance in between. So that would be the square root of y minus y over 2 is my base. And the height is the same thing because it's a square, so I can either write that again or I can just put a square here. So now I'm ready to write my answer. Volume is equal to the integral. Now we're doing the y-axis, so I want to make sure my boundaries are the y-axis boundaries. So 0 to 4 on the y-axis of my area dy instead of dx, and it says we don't have to solve. And so we're done. Now, if you did want to solve this, you could just plug it right in your calculator, and I would use x's instead of y's. It just makes it easier because that's what we're used to plugging into our calculator. Okay, so that concludes part 2 of our cross-sectional volume lesson.